Good day and welcome to our today's class on real analysis. In today's class, we want to prove that a sequence is monotone if and only if all its subsequences are monotone. This is a biconditional statement or a two-directional proof statement. The first direction of the statement will be that if a sequence is monotone, then its subsequence or its subsequences are monotone. And the second direction will be if the subsequences of a given sequence are monotone, if the subsequences of a given sequence are monotone, then the sequence itself is monotone. Then the sequence itself is monotone. I am going to start from the first direction of the proof. If a sequence is monotone, then its subsequences are monotone. Recall that a monotone sequence implies that the sequence is either increasing or decreasing. It is either increasing or decreasing. Therefore, let A sub n be an increasing sequence, and let A sub ni be its subsequence. Let A sub ni be its subsequence. If A sub n is increasing, then it implies that A sub n will be less than or equal to A sub n plus 1. Let A sub ni plus 1 be the next term in the subsequence. Now, by the time we begin to add 1 to A sub ni, we will continue to add 1 until we get to this next term in the subsequence. What do I mean by that? It means that A sub ni will be less than or equal to A sub ni plus 1. And this is less than or equal to A sub ni plus 2. And since it's an increasing sequence, it follows in that pattern. And that implies that what? A sub ni is less than or equal to A sub ni plus 1, less than or equal to A sub ni plus 2, less than or equal to down to less than or equal to A sub ni plus 1, which is the next term in the subsequence. Which is the next term in the subsequence. What are we trying to say? For example, if we have the sequence 1, 2, 3, 4, 5, 6, and it continues like that. That's our A sub n. And our A sub ni, let's assume it is what? 1, 5, 9, and it continues like that. By the time we pick the first term of the subsequence, which is 1, that's A1, and we continue to add 1 to it, we get the second term of the sequence, but we have not done what? We have not gotten to the second term of the subsequence. We add another 1, we get the third term of the sequence, but we have not gotten to what? The second term of the... By the time we continue to add 1, 1, 1, 1, we will eventually get to where? We will eventually get to the second term of the subsequence. That's what that expression there is telling us. And if that is true, then therefore a sub ni will be less than or equal to a sub ni plus 1. And that implies that the subsequence a sub ni is an increasing subsequence. Is an increasing subsequence. Now suppose a sub n is a decreasing sequence. Suppose a sub n is a decreasing sequence. By definition, we know that this implies that a sub n plus 1 will be less than or equal to a sub n. A sub n plus 1 will be less than or equal to a sub n. And that further implies that our a sub n will be greater than or equal to a sub n plus 1. And so, if a sub ni is the first term of the subsequence of a sub n, if a sub ni is the first term of the subsequence of a sub n, then it implies that what? It implies that a sub ni will be greater than or equal to a sub ni plus 1, greater than or equal to a sub ni plus 2, and it continues like that. And by the time we continue to add 1, add 1, add 1, we are going to do what? Get to the second term of the subsequence. We are going to do what? Get to the second term of the subsequence. That means what? A sub ni will be greater than a sub ni plus 1, and that is greater than or equal to a sub ni plus 2, which eventually will be greater than or equal to a sub ni plus 1. And that implies that what? A sub ni is greater than or equal to a sub ni plus 1. And that implies that what? A sub ni plus 1 is less than or equal to a sub ni for all I belonging to what? The set of natural numbers. Therefore, the subsequence a sub ni is a decreasing subsequence. And as such, we have been able to prove that if a sequence is monotone, then its subsequences are what? They are also monotone. That's the first direction of the proof. We'll go ahead now to prove the second direction of the proof. The second direction says if the subsequences of a given sequence are monotone, then the sequence itself is monotone. We begin by saying that let A sub ni be the subsequence of the sequence A sub n, and also let A sub ni be monotone. By definition of a sequence, by definition of subsequence rather, by definition of subsequence, we can recall that a subsequence of a sequence contains some or all the terms, contains some or all the terms of the sequence. Therefore, this implies that the subsequence A sub ni contains some or all the terms of A sub n. We can imply that A sub ni equals what? Equals A sub n. And since A sub ni is monotone, therefore the sequence A sub n is also monotone. And that proves that what? If the subsequence of a given sequence is monotone, if the subsequence of a given sequence is monotone, if A sub ni is monotone, then A sub n is also monotone. And by this, we have been able to prove that a sequence is monotone if and only if its subsequences are monotone. If and only if its subsequences are monotone. If you have gained anything from this proof, like and share with your friends and colleagues. Thank you. God bless you. I see you in the next video.